CS50.
Hello world, this is the CS50 Podcast. My name is David Malan, and I'm here again with CS50's own Brian Yu.
Hi everyone, good to be back again. So CS50 is taught primarily in C, as the programming language that we teach in the course at the very beginning. And a lot of students and people that we talk to very often ask, like, why C? Why is that the programming language that you've chosen for CS50 as the language to start out with? And I know that a couple years ago you answered a Quora post that was also asking the same question, but I thought I'd take today as an opportunity on the podcast to ask about that, push you a little bit on it, and just discuss that, the pros and cons of the programming language choice for this intro class.
Sure, in fact, allow me to encourage folks to Google Quora CS50 YC, because I dare say it's a very thoughtful response out there that actually took a couple hours to compose, so I can hit every point that I wanted us to hit. But it is a fair question, and honestly, this is one of those religious questions even that comes up all the time, especially when chatting with other teachers who teach computer science, who might be using Python or Java or C++ or C# or something else. It's kind of the go-to language when you meet someone new in computer science to talk about languages. So here we are, another FAQ. So I think it's only fair to disclaim that some of it is probably my own upbringing. When I took CS50 myself in 1996, Professor Brian Kernahan was teaching the class here at Harvard, and the course was under him and his predecessors primarily in C. In fact, even more of the course was spent in C, and so when I took the class, that was what I cut my own teeth on, so to speak. But with that said, with the benefit of hindsight, I do think pedagogically I have a more thoughtful answer these days, having now taught CS50 itself and having deliberately chosen to stay with that language. I think that it just has so many pedagogical upsides despite some of its simultaneous pedagogical downsides. So it's a relatively small language, and even within a handful of weeks in CS50 can we expose students to most of the language. We leave out just a few more advanced or more arcane topics like unions or function pointers and a couple of other syntactic features as well. But by the end of the semester, have students seen most of what constitutes C. Two, it's about as close to the hardware as you can get before you have to creep into what's called assembly language, which if you think C is scary, assembly language is way scarier than that, just syntactically and just how much control you, the programmer, have to exercise over what's going on inside the machine. That's a little too low level, I think, for students' first exposure to programming, whether they're major or non-major. But I think it's also at the tail end of CS50's time with C, it's just so wonderfully empowering to go on one day or 1 week having implemented, say, your own hash table, a particularly sophisticated data structure in C, and probably having spent hours and hours getting that data structure to not only be correct, but to be performant as well, as using as efficiently as possible your computer CPU cycles and memory. And then the next week, literally, at least in the way CS50 is structured, to go to Python, for instance, most recently or years ago in PHP, re-implementing the entirety of that data structure in just one line, using a dictionary or dict in Python or using an associative array in PHP. And I think that really speaks to the takeaways of abstraction that we want students to have in a course. You understand the underlying implementation details, but once you do, you can stipulate, I got that, now I'm gonna operate at and write code in a higher level of abstraction.
So you talk a lot about the pedagogical upsides of C. What are the pedagogical downsides, on the other hand?
Yeah, you know, pointers is probably the go-to answer here, right? With great power comes great responsibility. And admittedly, we do have to delve, or we choose to delve deeply into pointers and memory management more generally. The upsides of which, let me stipulate, I think, are that we can have even more interesting conversations about security and the implications for management of one's own data that you just can't have as effectively in higher level languages that protect you from yourself. But the downside, pedagogically and just technologically, is that students really do trip over their code ever more so, because in C, if unfamiliar, you have the ability to actually touch specific addresses in memory. So if your program has the illusion of, say, 2 gigabytes of space, you can touch every byte of memory there, for better or for worse, even if you're not supposed to. And the result of touching memory that you're not supposed to is often what's called a seg fault or segmentation fault, or more mechanically, just your program freezes or crashes or behaves unpredictably in some way. And that is super, super common. But I think that it gives you thereafter so much more of an appreciation for what a computer or a language or a runtime is doing for you. Java's references become more of an aha moment. Oh, this is nice. I don't have to worry about this feature this risk anymore. Python and other languages, Swift and Objective-C, can do memory management for you, but you know what that means and you know what's going on underneath the hood. And I just think that's a much better place to be in most any domain, to understand the underlying plumbing, at least at some point, and then build on top of it, even if you don't go into those weeds as much anymore.
So just to play devil's advocate, a lot of what you do at the beginning of CS50 is first creating these abstractions and then diving beneath them later, right? You start by introducing like that string, we're just going to call it a string, before later in the third or fourth week of the course revealing, okay, here's what's actually happening in an underlying sense. And you might imagine that you could take the same approach with programming languages, introducing like a higher level programming language like Python first and saying, all right, well, here's the easy way to do it without having to worry about all the underlying details. And then later on saying, all right, let's now take a look at a language like C and figure out like what's actually happening in Python when you're trying to run something like this. So how do you sort of make these decisions about, why do C first and then transition to Python as opposed to the other way around?
Okay, so one, I should note that it's not so much it's we. So you're just as guilty as I am in teaching it this way. Two, that would have been an amazing moment in like a Law and Order episode where on cross you get me to contradict myself like this. And that's actually a really thoughtful challenge. And I don't think in all the chats I've personally ever had about languages has someone framed it quite like that, to be honest. And for those listening in, this is not planned. I did not see this question in advance. So I think my pushback would be, it's, I think, harder to justify, at least in the context of one course, or it would be harder for me to justify in the context of one course, going from a higher level language, like starting with Python, and then diving more deeply into C, insofar as it probably doesn't really solve problems for students in the same way. Most of our students, and most students, dare say, who are studying to become software engineers or who just want to apply programming in other domains, they're not going to have to bother with C and its lower level optimizations and the performance that you can squeeze out of it. That's arguably, at least in the real world, I dare say more of a specialized field or specialized use case for a language where you really do want to be as close to the hardware as possible. And so I worry that approach, that sequencing of things would invite more of a who cares or why are we doing this now? Whereas if we sort of start from the lower level language and just give ourselves enough training wheels early on that we don't have to trip over some of the harder language features like pointers and what a string actually is underneath the hood, we can peel those off but still be in that original language and then step from that level to the next. So I do concede that there's a bit of built-in contradiction here, but to me it feels like the nicer balance. Start with the smaller, the more primitive language, layer on some training wheels, take them off, and then after taking those training wheels off, motivate a fundamentally different approach, different language altogether. Like that narrative just makes more sense to me.
Yeah, and I can definitely sympathize with that. Once you've motivated Python and you start to experience it, it's very difficult to imagine more situations where you would want to use C, especially for students for which CS50 is like their only programming class that they end up taking.
Well, and that too, honestly, I really do want students to emerge from CS50, whether they're taking it here on campus or just online at their own pace, like really not just being a programmer or a software developer, but really thinking themselves as a budding computer scientist, someone who can sort of think thoughtfully and critically about these very same issues so that ideally some of our students can actually have this same religious debate and maybe they'll fall on the other side of it, but at least they understand the primitives involved and the trade-offs involved with which to come up with that opinion themselves. But your question about pedagogical downsides too, I mean, there are other side effects. Like I dare say, and you know this better than anyone lately as you try to develop new problem sets for CS50 this coming year, that it's really hard to do cool things in C for some definition of cool. Like if we want to do more modern techniques that pertain to software features that students might see on their laptops and desktops and phones these days, like image manipulation or sound manipulation, or features that exist in a lot of today's most popular apps, it is arguably harder to do that in C because you don't have off-the-shelf libraries left and right that can solve these problems for you. And even if there are, their APIs, their usage might be a little more sophisticated than students are ready for after just 1 or 2 weeks of C. Case in point, like I have long wanted us to be able to introduce file I/O earlier in the semester so that in week 1 of the course, we could actually have students read data from a file. Now we could absolutely provide in CS50's own library 1 or more functions that does this, But as much as we've discussed internally how best to do this, it's not quite as simple as just having one function like get file or read file that hands you back an array of all of the lines. Long story short, we start to trip over some limitations of C where we might need a second function to help navigate things, to close the file, for instance, or we might need a specialized data type to represent the data from a file, at which point it just feels to me like now we're putting on too many training wheels and we're trying to use the language for what it's not really best for, at least in introductory programming contexts. So we pay that price, and there's a reason that CS50's early Psets are fairly textual and not nearly as cool, I think, as some of the mid or late Psets in the course.
Yeah, I definitely see that challenge. And for listeners who might not be too familiar with how C differs from other programming languages with regards to files and file manipulation, like different programming languages use different abstractions. So in a language like Python, for example, with one line of code, you can open up a file and read it so that you have the entire contents of the file that you can very easily manipulate and begin to work with. Whereas in C, there's multiple steps involved of first opening up the file, and you have to decide how much memory you're going to allocate, and you have to do a separate call to read the data from the file into memory. So it is a little bit trickier to be able to write problems that are easily accessible in C that deal with files, for instance.
Yeah, and honestly, another issue we've been wrestling with this summer is portability of code. So we have we have always in CS50 used a Linux or a Unix environment, even before my time, and that's sort of the architecture on which we've standardized for students. However, in recent years, the past 10 plus years, have we focused on making CS50's materials and software as portable as possible. All of our open source tools, including CS50's own library for C. But unfortunately, with C, do you run into some architectural specific details like the size of various data types? It varies by machine, sometimes what an int is or how many bytes or bits it takes up, a double or a float or a long. And so case in point, most recently have we been wanting to deprecate, that is, kill off a function that for many years in CS50's library was called getLong, because in recent years, we've migrated our own cloud architecture and students' laptops have essentially evolved into being 64-bit machines instead of 32-bit machines, which has had the side effect, if you will, of making longs twice as long as an int. So instead of 32 bits, they are 64 bits on most platforms like Linux and Mac OS, but not Windows. On Windows, a long is still 4 bytes or 32 bits, which means if you were to work on CS50's problem sets or programming assignments on your own Windows PC, and you are using the CS50 library and you use a long, you might actually only be getting 4 bytes of storage, not 8, which means you could actually have errors on Windows that you wouldn't with the exact same code on Mac OS or Linux. So even those kinds of frustrations come with C, but however, it's a less common case, I think, for students to be working on CS50's Psets on their own Windows computers and not using our environment like CS50 Sandbox or IDE or CLI50 these days.
Okay, so I also wanted to ask about like CS50's problem sets and whether C is the right language for these, whether you could imagine doing these sorts of problems in other languages. So like Game of 15, for example, which is a problem set that we assign in the 3rd week of the class approximately, and we ask students to implement one of those 15 puzzles with the sliding tiles. Like if you were to implement that outside of the context of a course, like is C the right language choice for it, or would you use some other language for that?
So I think I should first stipulate that C is rarely the right language for any of the problems that we might do in problem sets, because the reality is you can probably implement most CS50 problem sets more easily, more quickly, more pleasantly in languages besides C. With that said, Game of 15 essentially boils down to a 2-dimensional array of numbers, the goal being to arrange the numbers from top to bottom, left to right, from 1 to 15, leaving just one blank space in the bottom right-hand corner. And honestly, that is a problem that could be solved pretty readily in almost any language, because you're pretty much just navigating a 2-dimensional data structure and looking up, down, left, right to figure out if a move is valid, for instance. I think the GUI, which is a very simplistic GUI that we implement right now, could probably be done a little more pleasantly in other languages, especially ones that lend themselves to graphics. So we are not even using graphics in Game of 15. We are just using ANSI control characters so as to clear the screen instantly and sort of create the illusion of animation, and that's about as good as you can get with C until you use a proper library like the ncurses library, which, well, as an aside, we used to use years ago for fancier game interfaces. But I think Game of 15 is perfectly fine in C, but you could have a better UI more easily using other languages.
Okay, and what about some of CS50's other problem sets? So the one that comes after Game of 15 is usually Resize, which is like an image manipulation problem set where students are asked to take a bitmap image and scale it up, make it bigger, make it smaller, for example.
Yeah, so with most anything involving images, most any other language is going to be easier because odds are you can import some library and do what we are doing with resizing images with like one line of code. So yes, if I were in the real world to be implementing a program to resize images that I couldn't just download myself, like ImageMagick, which is a free open source toolchain for image manipulation, I would probably just use Python for that, though I gather Java is pretty good at image manipulation as well, but most languages have libraries built in that would make that easier. But I'd probably reach for Python these days.
Actually, that reminds me of another question that I was meaning to ask you. So you mentioned that C is the programming language that is taught in CS50, but was also taught in CS50 before you started teaching CS50. Whereas Python, that's a little bit different because a couple years ago, the class was taught using PHP in the latter half of the course. And recently you transitioned the class to being taught in Python instead. Was curious about that decision process. Was Python the obvious choice? Were there other languages you were considering? Or what was the thought process that went into figuring that out?
Oh, also a question that I think we answered on Quora some time ago. This too is an FAQ. So for many years we did use PHP, and that was a change we made early on in 2007 when I took over the course, whereas in recent years prior, the course had been introducing students to a bit of Ruby. I believe not for web programming, but just as a follow-on language to C. At the time, I didn't know Ruby. I did know PHP. PHP was certainly very much in vogue for web programming, and that was my pedagogical goal, to introduce students at the tail end of the semester to web applications, including some SQL and JavaScript and HTML and CSS, all of which, of course, were popular by then as well. And what I liked about PHP at the time was, frankly, its documentation was just stellar. Like, every page is standardized on PHP's website. It gives you really good examples that allow you to dive right in and use functions quickly. And it was just very accessible. And syntactically, PHP is just so similar to C, at least as we present it to students. Pretty much the only salient difference is like $signs need to be prefixed to variable names. But for the most part, almost every other construct is the same as in C. That was a really nice stepping stone to go from C to PHP. But the time came by mid-2010s that PHP was definitely falling out of favor. Python was becoming more popular. Ruby was definitely more popular, or at least was gaining more steam. So the first derivative of these languages was probably higher than PHP was at the time. And so at some point, it just felt like the right thing to do in terms of just trends, insofar as half of CS50 students are never going to take, we know statistically, another computer science course before, but they are going to go off to some other domain and apply programming principles in whatever areas of interest to them. We wanted them to have something that was a little more familiar and trending at the time. However, pedagogically, that argument could have been made even a few years prior. What really put me over the edge was just changes in industry paradigms when it came to web programming. So it was becoming increasingly common not to take PHP's approach of having every file serve as its own controller, so to speak. So index.php and foo.php and bar.php and baz.php, but rather to start routing all incoming HTTP requests through an incoming controller of sorts. Maybe it's all requests go through index.php and you somehow implement within that and more files your actual routes. And it got to the point where in CS50's problem set 7 at the time, CS50 Finance, we were going to provide students finally with a routing framework so that we mimic this industry standard paradigm where all of your requests are coming in through a central controller. And at that point, we were so adding on to PHP things that just existed not only in PHP frameworks, but in other languages frameworks like Flask for Python, that it felt like we were no longer using PHP for what it was so wonderfully pedagogically helpful for, which was early on the one-to-one mapping between text files, something.php, and routes in a web page. It was very nice and simple that if a student wants to implement a foo route, they implement foo.php, and a bar route, bar.php. But the reality is that is done more centrally in many frameworks these days, and so that is what finally put me over the edge. If we were going to so abstract away some of the underlying design features of PHP with our own mini framework, we might as well just adopt altogether a framework. And at that point, that opened the gates to any number of languages, and Python won out for us.
Yeah, Python's definitely seems to have gained a lot of popularity recently. I was just looking at last year's GitHub Octaverse report, which is the report where they take all of the GitHub repositories that are online and do some analysis and do some looking at the data there. And it looks like since 2014, Python went from the 4th place most common programming language for repositories on GitHub to 3rd place now, just behind JavaScript and Java. Although I guess on the flip side, since 2014, C seems to have gone down from 7th place down to 9th place. So I guess as a follow-up question to bring things back to why C, it looks like we eventually made the transition to Python because of changes in industry trends and because Python was getting more popular. In the longer term, maybe years down the line, do you see the course eventually moving away from C as a programming language?
Good question. Maybe. I mean, at some point, it's probably going to be a little clinging to the past. I don't know where that inflection point is. It doesn't feel like it's on the horizon. I mean, C is still quite popular. It's been with us for decades now. It's the foundation in some sense of many other languages, either in terms of its syntactic inspiration or just the underlying software, like the interpreters and the compilers we use are with high probability written in C, maybe C++ for performance reasons and so forth. So it's really not going away, I think, anytime soon. Whereas in industry, when it comes to web programming, again, the domain that we like to explore at the end of the semester, I think there's a more rapid rate of change when it comes to languages being in or out of vogue, or frameworks certainly that are in or out of vogue. And I should mention too that with Python, the other characteristic that put me over the edge mentally when it came to making this the final call was that Python is just wonderfully well-rounded too. It can be used and is used quite popularly for web programming, as with Flask or Django or other frameworks, but it's also very commonly used for scripting, for smaller applications, for command line programs, for data science applications, data analysis. So there's any number of different use cases, and PHP was, to its credit, designed for the web, but it wasn't really intended to be for data science, for command line applications and so forth. You can use it for that, and indeed we did for many years, but it just wasn't really designed with that in mind, whereas Python is generally pretty commonly found in both of those domains, so it just felt like the more versatile tool to have in your toolkit, so to speak.
So you've talked about some of the qualms with PHP, and you mentioned with C it's difficult to teach file I/O early on because it's a little complicated. What about Python? Any qualms you have with Python as a programming language, or things you wish were different?
Yes. I think its documentation is not good, certainly in comparison with something like PHP. I think Python's documentation really does assume a more comfortable audience, which I think is to a fault. I think that the language itself would benefit from just much more user-friendly documentation, and frankly more thorough documentation and more standardization of formatting thereof. Like right now, a lot of the Python libraries essentially have a paragraph per function, but it doesn't sometimes make super clear, especially to a less comfortable student, exactly what all of the arguments are and what their definitions of, what the return types are, what exceptions might be raised from a certain function. Whereas PHP and Java and a few other languages ecosystems have done, I think, a much better job at standardizing how the documentation is presented. It's perhaps a bit more verbose with bulleted lists or the formatting with which the information is presented. But for newbies, I think that's especially important and just pragmatically helpful to be able to skim documentation in some uniform fashion and not, as in Python is too often the case, cross-reference one function with another because it happens to have the same signature or the same arguments as this other function. I'd much rather the documentation just duplicate that information and maybe put it in one canonical place on the server, but have it imported in multiple places. I think the documentation could be much, much improved.
And speaking of documentation, I know that the canonical reference for C documentation for functions in the libraries are the function's man pages that describe as a manual of what the function does and how it works. But honestly, I found those to be somewhat arcane too, especially for students that are just getting started with C as their first introduction to programming and understanding what the functions do and how they work. They're not the easiest things in the world to read.
Oh yes, those are perhaps arguably worse. So you asked me only about Python. You didn't ask me to impugn C as well. But yes, Yes, and that's actually been an issue for us for many years, and we, for many years, tried to assuage this concern with our own website, which was called CS50 Reference. And what we essentially did one summer, some years ago, was a number of our teaching fellows, or TFs, kindly sat down and wrote more user or beginner-friendly versions of various man pages, and we encouraged students to use this web-based tool to look up information in man pages. Just this summer, though, have we switched to a new tool, which is CS50's own adaptation of man pages that you would find on a typical Linux or Mac OS system at man.cs50.io. So these are those raw, arguably arcane man pages, but what we've begun to do is using some fancy regular expressions or pattern matching, have we begun to overlay little hints on top of keywords or phrases that try to explain, similar in spirit to Help 50, another of CS50's tool, what it is some piece of language or some piece of English actually means in those man pages. And it remains to be seen if this is better, but this is more consistent with what we have done most recently with Help 50, which is we do not hide arcane error messages from students. We want them to see the raw output, for better or for worse, that they would see in the real world with any number of the tools that we use, but we do want to lower the bar to them understanding those error messages. So in the case of Help 50, a command line tool that parses programs output and then translates them to more human-friendly explanations thereof. Man.cs50.io does the same thing by showing the student, first and foremost, the actual, if arcane, man page, but we collapse some of the sections that probably aren't germane to the question the student's trying to answer. We put little yellow hover, on hover attributes, essentially, or JavaScript tricks to show them more information about certain phrases within the documentation, so as to chip away at that problem. It would be an non-trivial undertaking to do the same for Python. We're not there yet. I'm not sure if we will, but I think there are opportunities in both. And again, to its credit, I think PHP out of the box does this very well as a language.
You mentioned C's error messages, and that reminded me of another qualm I have with Python is just how long the tracebacks when you get an error message can be. That oftentimes when students are writing using frameworks like Flask in this class, starting to work with Python, when they have an error in their code, they get this incredibly long traceback that references so many files that they haven't even written and haven't looked at and haven't touched. And it can just be difficult when they're first getting started to like look at that and understand what their actual error is and where they made a mistake, as opposed to all of the different places where the exceptions are happening in the Python code.
Absolutely. And, you know, the rule of thumb would be we'll look for the line in that traceback that mentions your file and your file number. But we actually do, consistent with Help 50, with man.cs50.io, actually do try these days, the past couple of years, to help students see through that noise, if you will. So if you so much in Python as have a single line, import CS50 at the top, you don't actually have to call any functions. We, doing some technique called monkey patching, sort of importing other libraries and tweaking certain code settings, are we able to, for those tracebacks, highlight in yellow for students only those lines that pertain to their code, leaving black and white the lines of code that are unrelated to theirs, for the same purpose. We want them to see everything, we want them to see the noise, but we want to help them see through the noise, as by highlighting, much like Help 50 and man.cs50.io, portions that are actually relevant to them. So we hope too that this strikes that right pedagogical balance without sweeping too many details under the rug.
And I guess that kind of gets back as to the YC of letting people see the noise without sweeping the details under the rug.
Yeah, so I'd like to think, and the more we chat, I'm reassured to hear that I think we're being self-consistent throughout, but this is absolutely thematic. There have been, though, I'll admit, some Psets in the past where, honestly, we probably shoehorned in C where it just wasn't really very pleasant. So case in point, a few years ago, we had a Pset called Server where students actually needed to implement the guts of their own web server. So not a web application, not a website per se, but an actual program written in C that listens for HTTP requests and responds to them. The exercise, though, ended up really becoming quite the tedious exercise in parsing strings in C, which wasn't really the intent, because we do that, of course, very early on in like week 2 of CS50 when students parse strings and understand char stars and representation of strings as arrays of characters. But this one came later in the semester, and while it was a wonderful transition, I think, conceptually from C to web programming by actually implementing in C the foundation for web programs, it really was incredibly tedious to parse HTTP request lines. That is the sort of thing that is much more pleasant to do in almost any language, Python among them. In C, it really is a little frustrating. And so that I felt like now we are using the wrong language even for the right problem set.
Even in Python, I feel like having to parse the HTTP requests on your own would be a tedious task, and I'm glad that there are frameworks out there like Flask and Django that just handle a lot of this stuff for you and make it easier just to focus on the more interesting parts of web application design and development.
Oh yeah, absolutely. And that's why we use Flask. We don't implement Flask. But another years ago, we had a Pset inspired by Eric Roberts of Stanford called Breakout, which is that old school game where you can bounce a ball off a paddle and you try to break these bricks that are colorful in the sky. So it's actually non-trivial to do that in C, especially in our environment when you don't necessarily have a proper C GUI, a graphical user environment, like something called X Windows, because our most recent incarnations of CS50, of course, have students using web-based IDEs. So in a nutshell, back in the day when we were still using a virtual machine with students, the so-called CS50 appliance, which they ran locally on their Macs and PCs, we actually used C and some code that Eric Roberts had written, which itself was written in Java because Java allows you to do graphics a little more easily in a way that was also cross-platform. We had this bridge called the Stanford Portable Library, or SPL, that allowed students to implement this really cool interactive animated game, called Breakout, in C by using a nice pedagogically simplified library. But when we finally transitioned to more of a web-based environment, that actually complicated that. So it's been a few years since we've used Breakout as a game.
On the other hand, are there any problem sets that you think work really cleanly in C, where the solution in C is very elegant, very nice?
Mario, I think, lends itself wonderfully to C, although, of course, you could probably implement Mario in 2 lines of Python code instead of 6 to 10 or so in C. But I think some of the early Psets in CS50 could certainly be done pretty easily in C, like Caesar, which is a problem set on cryptography where students have to encrypt or decrypt information. That's nice because it lends itself to pretty simple user input. You type in a string and then you iterate over that string character by character and then do a bit of arithmetic using ASCII or Unicode values to convert it to the ciphertext or conversely to the plain text. So that works perfectly well in C. And even though, yeah, you could save a few lines in Python, C is perfectly fine for those kinds of string manipulations. Game of 15, where we began the story, I think works perfectly fine in C, even if the GUI might not be as pretty as you might get more easily with another language. The spell checking assignment that we do, where we give students 140,000 words in a big text file, and they have to load it into memory and implement their own hash table or some other data structure. That is particularly well suited for C when performance matters to you. You want to use as few CPU cycles as possible, as little RAM as possible, because with the power and capabilities of something like Python comes a non-zero amount of overhead, CPU cycles and bytes of RAM that are wasted on the overhead or the abstractions that it provides. And in fact, pedagogically, what's nice about doing that Pset in C and then re-implementing it a week or two later in Python in lecture is that students can see, oh my God, you can implement the spell checker in just a few lines of Python, despite 20 hours of coding in C on that same problem. But when you compare their performance side by side, you see that generally the Python version takes a non-trivial amount of more time to actually run. And so that's one of the goals even of that. Of course, I wouldn't want to implement something like CS50 Finance in C or really anything for the web in C. While you can absolutely do it, it's entirely unpleasant or way more time consuming than you'd want. So I think finance has always lent itself to PHP in the past, or more recently Python, though it is one that could be implemented in any number of other languages or frameworks, Ruby, C#, Java, or others.
Now that you mention it, the speller assignment really, I think, lends itself well to C, because whereas in Python there's really just one way to do that right, in C there are just so many ways, and it's been really cool to see students online that are all tackling the misspellings problem in various different ways, trying to figure out how to optimize it and make it perform the best. And we have this online scoreboard where students online can compete against each other to see how quickly they're able to spell check these documents by writing their most efficient implementation in C. And it's fun to watch people compete in that and try and figure out what the best way to do it is.
Yeah, well, I mean, so suffice it to say, with any discussion about language, everyone brings to the table his or her own, I think, preferences or religious beliefs. I'd like to think, though, that C has definitely helped us pedagogically solve some problems, or it has allowed us to implement a particular vision we have for the trajectory we want students to have from sort of day 0 to day n-1. It's certainly not without its downsides or costs in terms of cognitive difficulties or just actual technical bugs that students run into. But I'd like to think, certainly after this many years, that we have enough success stories of students exiting from the course, and even though they might never want to touch C again, that's fine, because truly at the end of the semester, where we end, for instance, here with the so-called CS50 Fair and a campus-wide exhibition of students' final projects, every year for like 11 years now of CS50 Fairs, have I genuinely been struck at how many students go off and implement something, create something, build something on topics, on languages, using tools that we ourselves didn't teach them in the course. And I would really like to think that is largely attributable not to the course per se, but to the scaffolding that the course happens to provide to students and the takeaways that they hopefully have, which is that they understand some underlying implementation details that are perhaps unique to a course like this, or the relatively few courses out there that do start at this level of abstraction that's pretty close to, but just above the level of hardware, but exit with more modern, with more powerful, higher level languages and techniques that allows a student who 3 months prior had never touched a line of code before to make his or her own iPhone application, web application, or any number of other tools. So I'd like to think we're doing something right here along the way. But
yeah, that's always amazing to see at the fair.
But do feel free, as always, out there to agree or disagree. Feel free to chime in with comments or your own perspective on languages or your own experiences, positive or negative, with C, with CS50, with Python, PHP, and a number of other languages. And indeed, we invite you to contribute your own ideas for the podcast moving forward, just as this week was inspired by a past Quora post. Last week's was inspired by a Facebook poll on machine learning. We would love to hear what topics are of interest to folks the most.
If you have ideas or you have feedback about today's episode, you can feel free to reach both of us at podcast@cs50.harvard.edu.
Thanks so much for tuning in. This was the CS50 Podcast.